Welcome to e-Shikshana program. Now I will explain the module 5. Okay, we have completed all other model. This is the module 5. In this installation is the burning of the waste with a high temperature and low temperature, and 3T process, time, temperature and turbulence, what are the factor affecting incineration, type of incineration, pyrolysis, design factor, and waste to energy. So many things, so many parts we will study in this. Module 5, first we will start with the incineration. Okay, what is incineration and what are the Okay, this and I already told part of this one. See, first one incineration, second one 3T process, and factor affecting incineration. Next one type of incineration, and pyrolysis, and we will go for design criteria of incineration, and energy recovery technique from the waste management. Okay, this is the syllabus we have to study in this module, okay, about installation. Now we go for this one, installation. I will explain briefly what is installation. It is the controlled combustion process, burning of the solid, liquid, okay, complete combustion process, burning of solid, liquid and gases, combustible waste. Gases and residues contain, okay, combustion material. Okay, it is the burning. It can be defined as controlled combustion process. It is the controlled combustion process of burning solid, liquid and gaseous combustible waste to gas, okay, and residue contain non-combustible material. Okay, the burning of the residue at the high temperature in a furnace is called incinerator. Okay, burning of the refuse, okay, at high temperature in a furnace called incinerator. Okay, incinerator, burning of the refuse at the high temperature. At the high temperature, I will show the furnace. High temperature burning about 1800 degree, more than that, so many that burning of okay, with high temperature. This is mainly waste, okay, burning of the waste. It may be this one e-waste, it may be hazardous waste, it may be this one biomedical waste. Okay, these are the waste, we are burning it, okay, in a solid, liquid, gases, combustible waste, gases and residue contain non-combustible material. The burning is done with a high temperature in a furnace. Okay, furnace called incinerator. This is called incinerator. Okay, understood now? This is called, that is, the process is called incineration. Process is called burning of solid, liquid, gases, combustible waste, residue. This is called, you can see the image, okay, you can see the image of this one, burning in the furnace. See this type of burning in the furnace, okay. This is the primary air, dozen burden, nozzle floor, okay, sand belt, sand, okay. Here is the waste, okay, burning of the waste here, okay. This is fuel gas, here fuel gas moves up, and here the burning, okay, material, admission of the material, okay, primary air, and this is the burner. This is called incinerator. Okay, here also you can see the here waste, okay. This is sand, it's a double part of this, and it is okay, in bed evaporator, air movement of the air, combustion, okay, heat absorption cell, okay. This is the high temperature burning. You can see the high temperature burning in this, okay. It is very strong, this one furnace, means if it burn 2000 or more than 2000 degrees Celsius, it won't melt. That type of furnace, okay, double partition, okay, and this is the process of installation, okay. This is the process of installation. Two parts you have shown. One is the this one, okay, this type. Another is this type, okay, conversion, this insulator. This is called insulator. So I will explain. Insulator can be controlled as a controlled combustion process, burning of solid, liquid gases, combustible waste to gas. To gas, okay, you can see the gas here, okay, you can see the gas, okay, by the burning of the waste, and a residue containing non-combustible material, okay, burning with a high temperature in a furnace called incinerator, okay, burning in a high temperature is called incinerator. See, this is the incinerator, burning with the high gas is produced. This is the process of incineration, okay. These are the two incinerator. This is mainly for the burning of hazardous waste, e-waste or biomedical waste. These two are using majorly for biomedical waste and hazardous waste. These type of chambers or furnace using. See here how much temperature it is a burn, about more than 1800 degree Celsius or okay, more than that, the temperature is burning. Okay, gases are here, it is produce the gases which are which will won't affect the okay atmosphere, this one, okay. This is the process of incinerator, okay. You understood, no? What is incinerator, what is okay incineration. See, now we go for the 3T process of incineration. 3T means first one is the time. First T is the time. There are 3T: time, temperature and turbulence. 3T incineration means okay, time, temperature and turbulence, okay. 3T process of incineration, okay. Time, temperature and turbulence is called 3Ts. 3Ts process of incineration. In that incineration, burning of the waste, okay, burning of the waste. What is the importance of time? What is the importance of temperature? What is the importance of turbulence? This is important, okay. When solid are exposed for sufficient time of turbulent atmosphere for complete combustion, when a fuel being burned, it is important that sufficient time available fuel burn completely, okay. That 100% of combustion means fuel fully oxidized, okay. Fully oxidation of carbon, hydrogen and other combustible element has taken place, okay. Time, very important. Time is how much percentage, okay, 100% of waste burning, okay, time taken, okay, what is the time taken to 100% of burning the fuel, okay, hydrogen and other, this is given an example for mechanical, this also for the, what we will say, what is the mileage, okay, what is the time taken for the, this in solid waste exposed to sufficient time of turbulent atmosphere, complete combustion, okay. This is same for our mechanical device also, like a bike, okay, how much fuel taken to complete burning, okay, give the mileage. That is also example we can give in a 3T process, what are time, temperature and turbulence, okay. Here solid waste are exposed for a sufficient time, turbulence, atmosphere for complete combustion. When fuel is burned, okay, fuel is burned, how much, okay, 100% of fuel burning, how much time is taken, okay, time is taken, okay. It is important sufficient time is available so that fuel burn completely. For the complete burning of the fuel, how much time is required. Okay, it is 100% of combustion means fuel fully oxidized and fully oxidation of carbon, hydrogen and other combustion element take place. Okay, understood now? Time taken for 100% of combustion means fuel oxidized, okay, and oxidation of carbon, hydrogen, other combustion element like has taken place. Okay, it is the time required. Okay, time required. Solid waste are exposed sufficient time required for the atmosphere combustion. When the fuel burn completely, okay, completely, see 100%, if the vehicle, if the fuel, 1 liter fuel burn completely, what is the time required? So this also in the solid waste, complete burning of solid waste, okay, what is the time required? Okay, 100% of the burning of the solid waste, what is the time required? Same example for fuel, they have taken for fuel. The vehicle, 100% of the, this one, vehicle, movement of the, this one, okay, 100% of fuel burn, 1 liter, what is the time required? Okay, this is the important of the 3T, what is the time, okay, exposed to turbulent atmosphere, when the fuel is being burnt, it is important sufficient time available to fuel burn completely. 100% it means fully oxidized, fully oxidation, carbon, hydrogen, other combustible matter take place. Now we go for the temperature. First one is the time over, time taken to burn complete 100%. Okay, the temperature range of incineration process vary from 5,500 degree to 10,000 degrees Celsius. Okay, temperature can be controlled above 7,500 degrees Celsius to ensure the adequate combustion below 10,000 degrees Celsius, ash melting, clogging of grate. The temperature controlled by the addition of dilution of air furnace are required. Okay, this is very important. Temperature in the incinerator process, temperature range may go to 5,500 degree to 10,000 degree Celsius in incineration process. Temperature range is controlled above 7,500 to ensure the adequate combustion, below 10,000 degrees, preventing the ash melting, clogging of grate. The temperature increases, okay, melting take place in the chamber, clogging of gate take place, okay, melting of the ash. The temperature is controlled by the addition of dilution of air, the furnaces as required. This is the process of second T, temperature. The high temperature, okay, how to control the burning, how to control control the melting and clogging of the grate. If it increased to 10,000 or above 7,500 degree, the temperature is controlled by the addition of dilution of air to the furnace if it required. Okay, adding, okay, air to the furnace if it required. Okay, or the controlling the temperature. If it is more temperature about 10,000 or 7,500 degrees Celsius, the melting is take place, clogging of the grate is take place. So the temperature should be controlled, okay, should be controlled. So the furnace required air, dilution air, that also dilution air, okay, furnace required dilution air, otherwise clogging and melting take place in the. This is the second process, second T. First T, time required, the temperature, burning temperature is high, how to control, required the air to the furnace. Okay. Then third one, turbulence. Turbulence ensures mixing the each volume of gas with sufficient air of complete burnt of volatile combined matter and suspended particulates. Okay, some turbulence or the mixing the waste within the bed of the grate is required. Oxygen makes the essential part of process of combustion. Okay. Turbulence ensures mixing of each volume of gas with the sufficient air for the complete burning of volatile combined matter and suspended particulate. Okay. Okay, this turbulence is ensure the mixing of volume of gas with the sufficient air for complete burning for volatile combustion matter and suspended particles. Okay, it is the turbulence ensure the mixing of each volume of gas with the sufficient air. Okay, mixing of volume of gas with the sufficient air for a complete burning of volatile combustion matter and suspended matter. This is called turbulence. Some turbulence are mixing the waste within the bed and the grate also required. Okay. Oxygen makes the essential part process of combustion. This is very important. This oxygen makes the essential part process of combustion. This is a turbulence. Turbulence ensures the mixing of each volume of the gas, sufficient air for the complete burning of the oxygen play important role, essential part of the process of the combustion. Okay, this is turbulence. Okay, volume of the gas with the sufficient volume of the air. Okay, mixing turbulence ensure the mixing of each volume of gas with the sufficient volume of air, complete burning of volatile combined matter and suspended particulate. Some turbulence are mixing the waste within the bed. Okay, oxygen is the important process of this one. See, 3T, first one is the time, second one is temperature, third one is the turbulence. This, okay, time, how much time required for complete the burning of that waste, okay, and 100% burning of the waste. Okay, temperature, if a temperature increases, the melting takes place, some air, external dilution air is needed. Turbulence, okay, mixing of volume of gas and sufficient completion burn of volatile combustion and suspended particles. Oxygen makes the essential part process of combustion. Okay, this is about 3T. Okay, already we have finished 3T. Okay. Factor affecting, okay, incineration, one by one we will go. First one is the temperature in the combustion chamber. This is the very, very important. In a combustion chamber, temperature increases, melting take place. Okay, melting take place. That is one of the factor affecting the combustion chamber. Okay, factor affecting the combustion chamber. This is very, very important. Okay. Second one, length of the time waste is maintained at high temperature. Okay, length of the time waste in maintained at high temperature. Time should not be wasted. Okay, it is maintained in a high temperature. Okay. Third one, degree of mixing of waste and the air. Operating conditions are specified. Each incinerator permit to ensure that these factors are present to promote complete combustion. This is very, very important. First is the temperature, high temperature of the combustion chamber. Okay, high temperature where you have to temperature in the combustion, it may be high. We have to maintain that factor affecting the incineration. Otherwise, chamber may burn or clogging take place, melting of the grate. Time, okay, length of the time waste in the maintained at a high temperature. When there is it should not be time take more burning. Okay, waste. Okay, in the high time should not take more in that. And the turbulence and degree of mixing of the waste and the air. Operating conditions specified each incinerator permit ensure the factor present promote the complete combustion. promote the complete combustion in the turbulence. Okay. These are the three factors affecting. First one is the temperature of the combustion chamber. Okay, length and time waste is maintained at the high temperature. Turbulence or degree of mixing of the waste and the air operating condition are specified in each insulator. Permit ensure that these factors present promote combustion. These are the main factor of the insulation: temperature, time and turbulence. These are the three factors affecting the insulator. Okay. What I told, what is the time, temperature and turbulence affecting. Type of insulator, there are different types of insulators. Okay, we can see the different types. Okay. See, burn pile, one the simplest and earliest type of waste disposal. They are basically referred to a collection of combustion matter piled on a open ground set afire. This is the burn pile, one of the this one. Okay. Second one is a rotary clean insulator, oftenly used for solid waste and liquid waste insulation. Can process solid, liquid and controllized waste. Okay, this is the third process. Sorry, the second is there. Okay, it is the rotary clean insulator. Okay, oftenly used for solid and liquid waste insulation. Can process solid, liquid and controllized waste. Okay, the second is a paralytical chamber insulator, okay, as known as controlled air insulation, okay, is the most reliable and commonly used treatment process in healthcare waste. Okay, this is for medical waste. There is important. Okay, controlled this one and treatment process for the healthcare waste. This type of insulator, paralytical chamber insulator is done. Okay. Next one, it is fourth one, single chamber insulator. Okay. Treat waste in a batches with insulation at a temperature range of 300 to 400 degrees Celsius. Operation like loading and de-ashing of the performed manually. Okay. This is the fourth type, single chamber insulator. Treat the waste in a batches with the insulation temperature ranges from 300 to 400. Operation and loading of this preferred manually in this single chamber insulator. And fifth one, drum and brick insulator, simplest type of single chamber insulator, should be used last resort. Okay, as causes air pollution. Okay, this is the drum and brick type of insulator. Okay, next one is the fluidized bed. Quickly and uniformly insulation waste used for municipal solid waste, low caloric waste and high caloric waste. Okay, fluidized is a very modern technology, fluidized. Okay, quickly and uniformly insulator waste. Okay, it is a very important, quickly and uniformly insulator waste used for municipal solid waste. Mainly we are using this fluidized bed, we are using for municipal solid waste, for low calories waste, high calorie waste, for the burning of low calorie and high calorie waste. Okay, this is the one of the important or the different type. First one, burning pile. Second one, pyrolytical chamber insulator. Okay, rotary clean insulator. Fourth one is the single chamber insulator. Already I explained. Okay, drum and this one brick insulator. This fluidized bed in a solid waste management, we are using major fluidized bed insulator. Okay, we are using the major quickly and uniformly incinerated waste used in municipal solid waste, okay, management for low calorie and high calorie waste. Okay, this is the process of different types of incinerator. Okay, different types of the incinerator. This is the different types of the incineration. Okay, understood now? One burning pile, second one rotary chamber, third one rotary kiln, fourth one single chamber, fifth one drum and brick, and fluidized. These are the different types of incinerator. Okay. Then we go for this different types. Some of the incinerator we are using in our municipality. This one, okay. This is the traveling grate, okay. Overfeed stroker, okay. This is the one of the. This is the movement of the grate. Here burning take place. Here waste are kept, okay. In this traveling grate, okay. Here burning take place. Wastes are kept above that, okay, above that, and this is the burning waste. Here coal hooper is there, here traveling grate, here waste are kept, here high temperature burning take place. This is the one we are using incinerator, okay, traveling grate is the incinerator we are using, okay. Next one we are using another incinerator. See, traveling grate, it consists of continual movement of feeder grate and one more burner grate. Feeder grate located directly under the charging hooper, okay, from which waste fall to the grate, waste partially dried with the feeder grate, okay. Waste are moved to the furnace from the hooper, while grate are actually stationary aspect for alternating reciprocal movement of the component stakes bar. Action of the stoker's bar turn the waste forward, next successive stool bar, burning rate adjusted, controlled by the speed of the stroke bar. Okay, this is about the this one. The consists of a continual movement of the feeder grate, one burner grate, feeder grate located directly under the charging hooper, from the which waste fall into the grate partially dried. Okay, in one this waste fall on that and it is partially dried. Okay, means okay, you can see here waste fall on this, it is partially dried in the above traveling grate. Okay, and this one too, this one is there, and waste moved to the furnace from the hooper, while grate actually stationary. Okay, this alternative reciprocating movement of the convenient stake burns action stroke bars turn the waste to overturn forward, next successive stool bar, burning rate adjusted, controlled by the speed of the stroke bar. This is the process of one of the incinerator, okay, burning the waste in the municipalities and everything. Okay, this is also done. Okay. Second one, reciprocating gates. Okay, another type of this. Here we can see the drying zone, burning zone in this, post-burning zone. See, different types of this one is there. Preheated air moves from down. Okay, preheated air moves from down. Okay, preheated air here also it moves. Three types of burners are there. A drying zone, here it is the drying zone. Okay, drying zone here. Here it is the burning zone. Okay, here it is the post-burning zone. Three types of zone. This is drying, this is burning, this is post-burning zone. Three types. Okay, here radiation, heat, access gas, everything it is there as shown here. Reciprocal. Okay. Here only drying zone of the waste. Here air is passed because it should not be burnt. Okay, melting should not take place. Okay, preheated zone, okay, burning zone, here post burning zone, preheated as zone. Okay, these are the different types of zones, okay, reciprocating, okay, gates. These are used for drying zone, here waste is dried, burning zone, waste is burned, post burning zone. In this we can see the radiation, how the waste is burnt, drying in how the waste is dried in this, waste is burned in this post burning zone. Okay, this is the reciprocal, okay, gate, reciprocal gate. Okay, see here, operation is similar to reciprocal gates, moves through the furnace by the rocking action of the gate. Okay, operation is similar to the reciprocal gate, but waste are moves through the furnace by the rocking action of the gate. Relatively new design wastes are burned as they move to the series rotating barrier. Okay, relatively new design of waste are burned as they move to the series of rotating barrels. Okay, barrels. Operation, okay, this one. And now we go for, already we studied insulator, okay, all the types of insulator, all the type already, okay, we have studied different types of insulator, okay, and different type, burning pile, rotting in, this all the insulator, and two images also we have studied, traveling rate insulator. This is used in the municipality, okay, and another one is the, okay, consists of continuum movement, this one, and another one is the reciprocal insulator. Here are three type, okay, drying zone is there, burning zone is there, post burning zone, okay, preheated zone from the below, okay, preheated zone from the below. These are the three types of grids, okay, reciprocal. These are the three types of grid. Now we go to the next is, okay, next one is a pyrolysis. Okay, pyrolysis of the many alternative chemical conservation process that have been investigated, excluding incineration. Pyrolysis received most attention because some organic substances are thermally unstable. Okay, we will burn in the incineration. Some organic, this is our thermally unstable. They can up to, upon the heating oxygen free atmosphere, okay, for the combustion of thermal, okay, cracking or condensation reaction in the gaseous liquid solid fraction. Pyrolysis is terms describe the process. Okay, this is very important. Some organic substance thermally unstable, okay, can upon heating with the oxygen free atmosphere, okay, through the combustion of thermal cracking and conduction, okay, some organic this is substance are thermally unstable, can by the heating it cannot be this one unstable. So pyrolysis is used, pyrolysis process is used, okay, term pyrolysis process is used. In contrast with the combustion process highly exothermic, pyrolysis process is highly endothermic, okay. For this reason, the term destructive distillation often used to alternative term for the pyrolysis. In contrast to the combustion process with the highly, okay, exothermic, the pyrolysis process highly endothermic. Very important, pyrolysis process is highly endothermic. For this reason, term destructive distillation is often used as the alternative term pyrolysis. Okay, very important. Mainly pyrolysis is endothermic, not a exothermic. Okay. For this reason, destructive distillation is often to use the term pyrolysis. Okay. This is about the pyrolysis. How it is this one, it contains the organic substances thermally unstable. By the burning it cannot be done. Now can be heating upon the oxygen free atmosphere. Okay. This is the term called pyrolysis. Okay. And this is the process of pyrolysis system diagram. Okay. Automatic feedstock transfer station. In this feedstock bin, fuel stake, gasified product vapor, vapor condenser, vapor pump, condensed liquid, pressurized gas storage. Okay, here is the temperature. Okay, super low NOx burner, natural gas supply, pressure gas. Okay, as discharge. This is the diagram which shows the pyrolysis process, how pyrolysis is done. Okay, how it is okay, here from automatic feedstock transfer system. Okay, feedstock bin, you can see here like a bin, fuel stake, okay, fuel content, gasified product vapor, okay, vapor condenser, okay, vacuum pump, condensed liquid, and pressurized gas storage in this. Okay, natural gas supply in this. Okay, it is burning this one. Okay, chamber. Okay, from this is the part we can find the pyrolysis. This is equipment, modern equipment in this pyrolysis process is done. Okay. And this is to acknowledge this video is taken from a YouTube resource. Okay, thanks to YouTube. Okay, I will display the video.